Hello, friends. Welcome to our Data Talk podcast, a weekly show where we talk with data science leaders from around the world. Today, we're talking with Saurabh Johri. He is the chief scientist at Babylon Health, and we're going to talk with him today about using AI to make healthcare universally accessible and affordable. Saurabh, thank you so much for being our guest today.
Yeah, thanks, Michael, for having me.
So can you kind of share a little bit about your journey, what's led you to work in data science?
Yeah, sure. So I don't really tend to call myself a data scientist. I tend to call myself just a scientist working on data. So,
Yeah.
bit of a kind of semantic issue there. But yeah, so I kind of started out studying genetics as an undergraduate. And that was when I was really first exposed to computational biology and bioinformatics. And so that was really one of the kind of key areas which was looking at the use of computational methods, statistical and machine learning methods to analyze large data sets. So that was my kind of first exposure to kind of computational methods and applying those to data. Followed by a master's in computational biology and bioinformatics at Imperial College in London.
Wow.
And that was really where I started to get my hands dirty with actually programming machine learning algorithms. These are, kind of fairly standard things back in the day, things like HMMs, so hidden Markov models, SVMs, dynamic programming kind of techniques for sequence alignment of DNA sequences and protein sequences. And that was really when I kind of got the bug, and that was, that I followed that with a PhD in population genetics. That was really where I kind of really went deep into some of the literature on statistical learning approaches, so particularly Bayesian approaches. And those are really prevalent in population genetics and evolutionary biology, where you're trying to estimate parameters from kind of quite complex processes, but most processes are relevant to the population that you're studying. And so that was really my key kind of thing that really fascinated me, was actually the Bayesian approach to statistics and machine learning. And really kind of the key thing that I was super interested in was the computational methods for doing inference. So you have some model and you have some data, but actually how do you learn the kind of elements of that model to allow you to make predictions or to understand the process of generating your data better. So that was my data science journey in a nutshell, really. It's kind of a condensed view of it, but hopefully that gives you some oversight of what I've been doing.
Yeah, that's fascinating, and what an amazing background. What originally led you to get into genetics? Because it's fascinating that you chose that. Was there something driving that interest?
Yeah, so I come from a background where I have doctors in my family. My father's a surgeon. And it was something where I knew that I didn't want to go into medicine, but I wanted to study something which was not, well, at a young age, it's not something which you're taught particularly well at school. And that was around the time when there was promise for genetics, particularly genomics, so the Human Genome Project. And there had been some kind of personal, personal illnesses in my family where cancer had been, had a relative who was afflicted by cancer. And really the promise of genetics was one where, that was something which we're really wanting to see actually how, doing research into genetics would actually potentially come up with some solution to some of these big problems. And so then I started to learn genetics, and actually what you learn when you study genetics and actually start practicing is that a lot of the time is spent in the lab. And I found that to be, enjoyable for the first few months. And then after a while, it was, you can do a lot of these same experiments in silico. So that was really when I kind of discovered bioinformatics and computational biology. And that was really, once I got that, I was like, well, I could be much more productive by running these experiments on a laptop versus actually preparing agents, preparing solutions, and doing all of that testing in the lab. And so that's why I kind of took the path that I did. And it served me pretty well. It was really enjoyable. I learned a bunch of skills which I wouldn't have done if I had stayed the course and continued in kind of wet lab science. So I started to kind of get exposure to programming languages. Started off on the deep end with C, which was horrendous, and then then got exposure to these kind of approaches for doing statistical learning and machine learning, and just still to this day completely fascinated by the.
Did programming come easy for you?
I have to say it didn't, actually. I think that was because I started off with C++. So we very quickly flip-flopped from doing C++, learning about pointer arithmetic and all of that, to going to the kind of complete opposite in Perl. So kind of showing my age here, but, doing Perl was a complete, writing, complete opposite to doing something so formal as C++. In Perl, you can write the same function or the same program in tens or 20s of different ways, whereas in C++, you can do the same, but it's actually, there's generally a stricter language, a much more formal language. Especially when I had the fundamentals from a formal language such as C++, and then adapting that to be able to quickly script to answer the problem I wanted, that was really what excited me, actually, knowing that actually I could, a few lines of code, I could get the answers which I was kind of after. I think it was a good primer. Essentially, having a simpler scripting language to really, develop and innovate quickly was the thing which really kept me interested. Yeah.
And then when you ended up going into your doctoral program, there's a lot of investment in your time, research. What was your goal? Like after you finished your PhD, like what did you want to do?
So at that time, I wanted to remain as a research scientist. I wanted a career in academia. That's actually one of the points which I left out. So I finished my PhD, and then I had 5 years as a postdoctoral research fellow at Imperial College. And this, again, was working in healthcare, particularly looking at integrating mathematical models with population genetic methods. So you have mathematical models which tell you about how a disease might spread in a population. So in particular, I was looking at poliovirus. So how does polio spread within the population? So you can write down a relatively simple mathematical model which tells you over time this is how many people in the population that it affects. But then also we were integrating methods from population genetics. So we had genetic sequence data from poliovirus. And this was really part of the effort to try and eradicate poliovirus globally. And so we had genetic sequence data from poliovirus, which has a what's called a high case infection ratio. So what this means is that for every 1,000 people, or I think it's 1,000 people if my memory is certainly right, for every 1,000 people who are infected with poliovirus, only one of those actually exhibits the symptoms of polio. And so that's quite different to other infectious diseases where if you're infected, well, it's pretty obvious you're infected. The problem there is that actually, it's a large number of people who are infected but are not symptomatic, and so therefore it's quite hard to control that infection. And so what we were doing is we were taking genetic sequences from certain reservoirs, so it's transmitted through a fecal-oral route. And so we were trying to use that genetic sequence data to work our way back, because genetic sequences have a clock. So because of how much those sequences have evolved over time, there's a rate at which the sequences evolve. And so we were able to work out backwards in time actually some of the interesting parameters about the population we were studying, to say actually how much of this virus does exist in the population, given we can count that from the genetic sequences. So in a sense, just to summarize, you have a mathematical model which goes forward in time, then you have a set of genetic sequences which you can track backwards in time, both using, so the forward in time model is mathematical, the reverse time of the genetic sequence is a statistical model. and then you're applying a bunch of statistical machinery on the top to try and do the estimation of those parameters. And that was really where I kind of applied some of the approaches to Bayesian inference. Really, really, it's quite a challenging problem. So I think just to give you a bit more context, where I've kind of been in my career, it started off as and I've remained in healthcare. And that's really what drives me, actually, just applying these methods to problems in healthcare. And I think that's just come from actually having been raised in a family of healthcare professionals. So my father, as I said, is a surgeon. There's other doctors in my family. So, yeah.
Yeah, that is so cool. So what does your family say about your work? Having some medical professionals there.
Yeah, so I remember having this debate since I was a young kid with my dad. He used to say, this is crazy that, because I used to, see these large medical textbooks, which were sitting around the house, and I would see various, cousins actually revising these really thick medical textbooks.
Yeah.
And I would always think it's just, and this is not to kind of, this is not a disparaging remark about doctors, but I did think, well, we can probably apply some, quite sophisticated computational methods to actually, ingest that data which exists in medical textbooks, to be able to, in some ways, replicate the reasoning processes which a human doctor uses, and apply those, in a setting on a machine where we can give that to people. And it wasn't something which I, considered seriously until, after I'd finished my PhD. Those were the debates I remember having with my father a long time ago, and then, kind of forgotten about those things. And then, all of a sudden I see this job advertised at Babylon, and they're looking to do the same thing. And I'm like, wow, that's a tailor-made job for me. So, yeah.
That is so cool. So tell me about how did you hear about Babylon, and what was the process like for you to make the decision to join the team?
Yeah, so I heard about Babylon because, I wanted to get out of academia. I had been in academia for some time. And as much as I really enjoyed my time in academia, I was looking for a new challenge. I was looking actually to kind of break into data science. I thought, well, up until, I don't really know how long data science has been a kind of a term which is being used.
Yeah.
But I remember at the time thinking, oh, well, that sounds cool. Lots of data, you can apply these methods at scale, probably. So I started looking. Actually, I started looking. It was actually a girlfriend of mine in the past. She looked at my skill set. She knew I wanted to get in the industry, and she found this job advert. She's like, "Wow, this is perfect for you." And I looked at it. I was like, come on, the office is down the road from my house, so that had no bearing on my choice, my decision, but it was an added bonus at the time. So yeah, that was how I found Babylon, and it's a fascinating place. For your listeners who don't know much about Babylon, I encourage you to kind of visit the website. We have a bunch of talks on YouTube as well. It's a fascinating place to work, incredibly smart people. So actually one of the hesitations I had when leaving academia was that, oh no, I'm going to leave and I'm going to go into industry, and I'm not going to have the same kind of mental stimulation that I had in academia, where I was, going into the kitchen, having a coffee, and I would bump into someone and have a great conversation about science or about methods or just generally about life. And then when I came here, actually I found, the people who were already in the team. It was a much smaller team at the time, but even then we had the kind of, we had the foundations of a really smart team. And now the team I have here is just amazing. Some of the smartest people that I've ever worked with. Very nice, humble human beings as well. So those two things together just make this a really great organization to work for. And, the mission, I think you kind of summarized it in your opening remarks that, it's a mission which is, truly worthy. It's to provide affordable and accessible healthcare to as many people on earth as we can. And that's something which motivates not just the team, but actually when we go and tell people about what we're doing, when we go to conferences, so we attend conferences a lot, but when we go to these conferences, we just see actually how so yeah, it's still hugely motivating for me and the rest of the team, not just the team doing the artificial intelligence and machine learning, but throughout the rest of the organization. So,
yeah, what is the reaction when you're speaking at conferences, going to conferences, meeting with other data scientists, and sharing about the work that you're doing at Babylon? What is the reaction?
The reaction is that, while you guys are tackling a lot, we're not just applying a set of machine learning techniques, which, for example, we haven't just gone onto GitHub and pulled down the latest version of somebody's code. We're actually having to, and that's why I made the distinction between, I don't really call myself a data scientist, but more of a research scientist. We have research scientists here. And that's because we can't, just pull off code from GitHub and start running it. We have to, in a sense, develop a lot of the methods which we need ourselves. So I'll give you a really great example of that. One of the things which we've published in the last year and a half, so we published this in NIPS last year at the Approximate Inference Workshop. It was a paper on actually how to do Bayesian inference at scale. So, for your listeners who are familiar with these techniques, it's often thought that, Bayesian methods provide huge benefits, uncertainty, quantification. They allow you to incorporate prior knowledge and belief updating. But actually, computationally, they are extremely challenging. And so, one of the bits of research which we published and has actually gone into production is actually how to use approaches from deep learning to actually give us an automatic boost in that inference procedure. So how do you go about doing so-called amortized inference? And so that's something which we've spoken about at conferences. We've presented that work, and actually it's gone very quickly from being in research to production. And that's something which I never thought would be the case. I just thought it's going to be a research project and it's going to be in research for a long time. But, that's one of the benefits of working in a startup. You have the resource. Well, we're not really a startup anymore, but, you have the resource and, you have the technical expertise. And actually you have people, world-leading experts who work with us to advise us on these things as well, because they're also motivated by the same mission. So, and it's not just the Bayesian inference stuff. It's, we have a team. And so that's why we call what we do not just machine learning, because we have, we're not just doing machine learning. We're doing kind of formal methods for knowledge representation. So we've built here one of the largest knowledge graphs in medicine. We're kind of pioneering in, because actually everything the patient does when they have an interaction with our AI through the chatbot is through natural language processing. So we've written a bunch of quite nice pieces which have been published also on actually how to understand natural language, but also using traditional methods, so computational linguistic methods. And I think, going beyond just the machine learning kind of approaches, one of the things which we're really excited about, which I'm very excited about, is this whole area of causal inference. And this is kind of sits slightly outside of machine learning. It's an area which has been used traditionally in biostatistics and sometimes even in economics. And what we're doing is developing a series of kind of methods here to actually learn the true causal structure of the data generating process. And we learn that causal structure and use the model which we've learned to do counterfactual simulations. So because we can do those counterfactual simulations, we're also able to look at the effect of intervening on those populations. And the nice feature of these methods is actually you can do this in observational data sets without actually having to perform a randomized control trial, which would typically be the case. And so we're pioneering here as well in developing a bunch of causal discovery algorithms which are in draft. We'll be submitting those for publication soon. And again, those will be going into our product. We've got a paper sitting on the desk one day. We put it into a prototype. We start to expose that to the business, and we just see that they see the potential in these things. And it's just basically we have a very, very strong team here, and they know what we are trying to achieve, and the research comes up and it's kind of motivated by what we're trying to achieve, and everyone's very aligned with that. So.
It's beautiful. Can you talk about some of your favorite products that you're currently working on, stuff that you're really excited about?
Yeah, so I guess one of them, which I've just spoken about, we don't really have a name for it yet, but it's, so if I just explain what Babylon is as a system, it's, so what we're trying to do is provide an AI for healthcare. So as we know, healthcare isn't just about when you're sick, but it's also about, trying to prevent you from becoming sick. So, sick care and healthcare. So on the sick care side of things, when a patient is sick, they interact with our chatbots. And then we have a set of reasoning systems on the back end. So this are Bayesian probabilistic graphical models, which are reasoning about your underlying condition based on the symptoms and risk factors which the user has told us that they have. So that's one of the kind of key products which I'm personally very kind of proud of.
That's very exciting.
Not just the reasoning system. That's not just the reasoning system in its own right. To access that reasoning system, you have to go through the chatbots. And as I mentioned previously, the language processing abilities which we built into our products are really quite sophisticated. They have to handle quite, there is natural language processing, and then there's natural language processing for medicine. It's a very specific expertise which is required to understand medical, medical symptoms, particularly because patients don't always express those medical symptoms in a medical manner. Often they use colloquial language, and we have to be able to pick up that colloquial language. The classic example I give is, or the one that Ali gives, our founder, is that a patient might be telling us that, they might be saying, my stomach is really killing me. So how do we know that that is severe stomach pain as opposed to an act of violence? Well, we have to be able to distinguish between the various ways in which a patient expresses their symptoms. And so you can think of, thousands of other examples in which, patients express themselves, often using quite crude language. And so we need to have flexibility in our natural language understanding to be able to cope with those things. And actually, if you think about it, the impact of a patient or the AI understanding that natural language process, the natural language understanding, has a huge impact on the quality of the diagnosis which we can give. So that's just two products within the larger products which I can talk about, which are hugely impactful on the sick care side of the spectrum. We're going to be extending that now to do treatments. So we're adding treatment functionality into that, and that is again based on a purely principled mechanism for doing decision making. So that is looking at not just the likelihood of you having a disease, but actually the cost or the utility of providing some treatment. So you have some disease. Actually, what is the cost for you of an individual, either financially or in terms of healthcare, of us providing a recommendation for a treatment? So, for example, you may have a kind of contraindication in your family history, and we have that family history because we store all of this information about you. We store all of this medical information about you as a user. So we're able to use different kind of data points about an individual to update our reasoning process. So that's just the kind of sick care part of what we do. And then secondly, what I was kind of describing is the methodology behind a product which we will be releasing next year. And this is the so-called digital twin. So this is, digital twins are kind of fairly familiar to people in the kind of, in various large-scale engineering organizations where you have a digital replica of, let's say, a factory, and you're trying to assess the impact of, changing various conditions within the factory. Likewise, we have data points of an individual, and because we have those data points, we're able to present the individual as a kind of virtual avatar. in. And so because we have that avatar, now we can ask a series of counterfactual statements about that individual. So counterfactual statement is essentially just a what-if question. So, information about a user's diet, their exercise habits, their nutrition, their kind of smoking habits, or whatever it may be. And because we have all of that information, and because we've built these large these large-scale models in the background using these causal discovery methods, we're able then to say, what if you as an individual, what if you as an individual just exercised a few more hours per week? What would be the impact on your health? And so these are some of the things which we're developing. They're in development now, and we'll be releasing those into product next year. So that's hugely exciting.
Yeah, that's super cool. I'm curious about your view on like data ethics, and this came up. I shared the story a couple weeks ago, but my son, I was playing with this app called Woebot, WOEBOT, and it's an app to help kind of gauge your mental health, and you kind of check in whenever you can. And I was checking in, every single day, just kind of to say, how are you feeling today? And it kind of measures, good days, bad days, and you can work on things like what are some things I can do to reduce stress and provide advice. And it's a very simple AI. It's still in the development phases. And so I wanted my son to kind of play around with the bot. And so he was kind of answering some questions. Some of it was you just kind of press on your answer instead of typing things in. Well, I'm not sure what he did, but all of a sudden the Woebot thought that I was suicidal and started suggesting all these different things like I should call this number immediately. And so that made me think like, well, shouldn't this bot, like if I'm truly suicidal, wouldn't the AI have almost a responsibility to contact an authority? Like, for instance, I'm thinking like on a health situation, if I'm suffering from a stroke and I'm answering the questions and the AI is like, this person is probably having a stroke based on the answers, but the person may not be in the right state of mind or ability to be able to call, a health professional. Like, what's your kind of view on that? Because it's difficult.
It is very difficult. And yeah, I mean, I guess the answer there is that certainly in our case, we have a bunch of safeguarding messages around the use of our product. So, for example, we one actually aspect of the product which I didn't touch upon is that we have diagnosis, but we also have triage. So triage is literally the signposting of where you should go to seek medical help. So let's say you have appendicitis, you should probably go to the ER, versus if you have just a blocked nose or headache, you should probably just stay at home and take some pain relief. So that's the triaging function. So what we've built into our product is actually for certain things like stroke, there is some medical safeguarding here. So the moment we actually start to understand that this person has, for example, a set of symptoms which are highly indicative of something quite severe, we will actually just say to them, actually, no, stop the flow and actually seek medical advice. So in the case of those serious conditions, we have those safeguarding procedures in place. In the case of the mental health example that you gave, that's slightly more challenging. And this is an area which we are going to be focusing a lot more effort into. Again, we have safeguarding. So in the UK, for example, if you kind of mention that you are suicidal, then you'll be directed to in the UK we have the Samaritans, so it's a particular phone number we can call and seek some kind of counselling on the phone. But I don't think I have a perfect answer for that, nor do I think the perfect answer exists right now. I think that's something we are particularly interested in trying to move this AI field forward, particularly by engaging with ethicists, experts in AI as well. I was actually at a talk over at Oxford with one of my colleagues, and who's the chief medical officer here. And so we presented our work at this college, and this was largely a medical audience. And at the end of the series of talks, there was actually a panel on the issues of ethics and the issues around using artificial intelligence in healthcare. So some really fascinating points came up throughout the course of that, things which I certainly hadn't thought about previously, but also different opinions. So, doctors who are actively practicing and then potentially using AI, or in some cases, think about, radiographers, for example. There's a lot of hype about potentially should radiographers be training anymore, because actually we know that these deep learning approaches are so kind of accurate in some of the functions which they perform. There's a lot of ethical questions all over the place, and I think it's right for people who are practicing machine learning, artificial intelligence, to think about these things.
Yeah, that's brilliant. It's exciting to see all the work you're doing, the work that Babylon Health is doing to help improve healthcare, and I like the way you put it, sick care, because I never heard that term, but I like distinguishing those things. I think that's the right way to view it. And it's exciting to hear about development of AI to help diagnose, help figure out how it can get better, be healthier. It's a very exciting time. It's awesome to see Babylon Health taking the lead. Certainly the work that you're doing. Before we go, we have a lot of people in our data science community who might be interested in working at Babylon Health or working to help with AI and healthcare. Do you have any advice for how to interview, what type of skill sets you're looking for somebody who's looking for that type of role?
Yeah, but I guess there's a couple of things here. So often we get asked, I get asked, and my colleagues get asked, what should I be studying, or how do I get into a successful career in data science, machine learning, whatever it may be. And my answer to that is actually don't always just focus on what the hottest new thing is. The reason for that is that, if it's a hot new thing, then there's obviously going to be a lot of people who are looking at that. And actually, those hot new things can easily become commoditized. And we're already starting to see that. In terms of actually successful hiring, I guess that depends very much on the organization which you're going to. I think the one thing I would say is what I look for is people who are strong research scientists. And that's not always going to be the case. So another organization, you might want to be hiring a science team. And there, I think you as a hiring manager or somebody who's responsible for hiring in that organization has a responsibility to be very clear about the role which you're hiring for. So in other words, if you're hiring for a data scientist, don't hire a research scientist, and vice versa. It's they have to be clear about what the job is that they're doing. Otherwise, it's likely that there might be some frustration there. And actually, you're probably not going to get what you're expecting from. I think in terms of, again, just going back to what I look for is strong fundamentals, strong fundamental understanding of statistics and machine learning. So if I was going to give some advice to somebody starting out, I would say actually just focus on the foundations. Go back to the simple stuff. Go back to, linear algebra, calculus. Even though frameworks exist now, TensorFlow, PyTorch, and these other tensor-based frameworks, which mean that you don't necessarily have to know the details of, how to invert a matrix or pass a gradient through a system. I still think it's worthwhile spending time on effort into understanding actually what the fundamentals are which power these systems. So I think that gives you a lot of intuition actually how these algorithms are working. And particularly in a research environment where you're trying to figure out how to solve a new problem, often you'll have to go into the literature to read the kind of the latest papers. And so one of the things which I really look for is actually you have an understanding of the foundations. Would you be able to read a research paper, replicate the work which was in the research paper, to assess it and benchmark it against some system which you may be developing? So, I guess just to repeat myself, it's technical or solid technical foundations.
Awesome. Well, Saurabh, thank you so much for being our guest in Data Talk. It was awesome learning from you. Thank you so much for sharing your insights. I know this is going to be extremely valuable to our data science community. For those that want to get in touch or follow the work that you're doing, what's the best way for them to do that?
Yeah, I'm not huge on social media. I am on Twitter, and I hardly tweet. So I'm more of a retweeter. So I have a Twitter handle. I actually had to, before this session, I actually had to go and check my Twitter handle, so it's quite embarrassing. So I'll give it. It's at Saurabh_Johri. I can send you the Twitter.
Okay, wonderful. And what I'll do is I will I'll put it on the Experian blog to make it easy for them to follow you on Twitter and also on LinkedIn. That way they can keep track of your work, and also if you're speaking at conferences and all that. And what I'll do is I'll make the short URL will just be ex.pn/Johri, which is spelled Johri. Again, for those listening to the podcast, just ex.pn/Johri. That'll bring you over to the Experian blog post with this video, the podcast episode, along with a transcription and links to Saurabh's LinkedIn and Twitter profiles. So we'll definitely do that. Thank you so much again for your time, and hope we can chat again soon. Awesome work that you're doing.
Thanks, Michael. That was great. With that, are we off?
Right now. See you.
Oh, no, sorry.